All right, y'all. So I'm bringing up this real quick for the first problem and a few problems in, like I think 7 and 8 or 8 and 9. You got to know this in behavior chart. Okay. So remember, it goes by the degree, which is the highest exponent. Highest exponent will either be even or odd. And then we look at the lead coefficient, which is the number in front of that variable, with the highest exponent being either positive or negative. So going off of that leading term, we determine what the end behavior is going to be, okay? So I'm going to share problem number 1. So for number 1, they're giving me f of x equals negative square root of 2x cubed plus 2x squared minus 5x plus 5. And they want to know the end behavior. So y'all, my leading term is the negative square root of 2, x to the cubed. 3 is my degree, which is odd. And that lead coefficient is a negative square root of 2. So I'm looking for the picture that has an odd degree and a negative lead coefficient. So I'll look at my chart here. So odd is in the second column. We had a negative lead coefficient. And since we're odd and negative, we need the choice that has the graph going downhill. All right, y'all, so I want downhill, left to right graph. So I would pick B for that. So it looks like you actually got a type of B in there. All right, so that and we go to the next. So this one wants me to determine if 4 is a zero of the following. All right, y'all, let me write that
Can
down.
you go back to one really quick, just so I can write something down?
Oh, number 1.
Okay, thank you.
Okay. Hey, y'all, so let me write that. F of x equals x cubed minus 10x squared plus 12x plus 31. And they want to know is 4 is 0. So if 4 is 0, that means you're going to plug 4 in for all those x's, and we're going to simplify it. If it's a 0, then the answer better be 0. If you get any other number than 0, then that means no, it's not a 0 of that function, okay? All right, so we're looking for an answer of 0 for this to be a 0. So we're basically finding f of 0. So we're going to put in f of 4, my bad. So 4 is the number I'm checking, so I'm doing f of 4. So that'll equal 4 to the third minus 10 times 4 squared plus 12 times 4 plus 31. All right, so let's see what we get here. 4 times 4 times 4 is 64 minus 4 squared is 16. And then 16 times that 10 gives me 160. All right. 12 times 4 is going to give me 48. And then at the end, I got a plus 31. All right, y'all. So let's add these and see if we get a 0 out of that. All right, so I got 64 minus 160 plus 48 plus 31. All right, I get a negative 17 for that. So since I got a negative 17 and not 0, that means we're going to put no for that answer. And okay, so I got, okay, over here is a no for that one. Okay, so that's all you're checking. Put your number in, And if you get 0, it's yes. Any other number is no. All right, y'all, this one I'll write down. F of x equals x to the 7th times x minus 3 squared times x plus 2. They want the multiplicity and the zeros on these, okay? Now notice how they got the answer. We got to start with our smallest zero, the middle zero, and then the largest zero, okay? So let's work this in real quick. All right, so these exponents are all going to be the multiplicities. Now, we don't have an exponent after the last parentheses. So do y'all remember what I would write here as my multiplicity?
1.
1. There you go. Okay, y'all. So 3 factors. So I'm going to have 3 zeros. So now we just set everything equal to 0. So start with the x. X equals 0. We're not going to be able to do nothing else with that. So that means 1 0 will be x. X minus 3, I'll set equal to 0. And then the x plus 2, I'll set equal to 0. So these two, since we had numbers with the factors, we got to add and subtract. So I'm going to add 3, and I get x equals 3. And then here, I'll subtract 2 and get x equals negative 2. So let's see. Our smallest zero will be negative 2. It'll have a multiplicity of 1. My middle zero will be 0. It'll have a multiplicity of 7. And then my largest zero is going to be 3 with a multiplicity of 2. So y'all, we're going to go put that in now. What do we say? Negative 2 here. And it had multiplicity of 1. 0 is my middle zero. It had a multiplicity of 7. And then my largest zero was a 3. And it had a multiplicity of 2. All right, so set the factors equal to 0 and then use those exponents for your multiplicities. All right, let's see what number 4 has. Oh, so number 4 is the one where we actually got to factor it to get our zeros, okay? So I got an x to the 3rd minus 9x squared minus an x plus 9. Now, y'all, on this problem, everything will be identical to mine other than the 9. So y'all have either a 7 and a 7 there or a 5 and a 5. It'll be similar. So it's going to work out the same way that this one we're about to work out goes, okay? So these were the 4 term ones, and I put them into 2 sets of factors. So we're going to group the first 2 together and the last 2. And I factor out the greatest common factors. Now, on the second group, we at least have to factor out a 1, okay? All right, so you got an x to the 3rd and a 9x squared. The greatest common factor between those two is going to be x squared. See, that's got an x squared and that's got an x cubed. So they both at least have an x squared in them. Now we'll take both of these, divide out the x squared and put that into parentheses. So x cubed divided by x squared, 3 minus 2 leaves you an x minus 9x squared divided by x squared. The x squareds cancel and leaves me a 9. So my first factor becomes x squared times x minus 9. Now remember, the second GCF that I factor out will have the same sign as the third term. So since these x's are negative for us, that means we're going to factor out a negative. And y'all, what can I factor out between an x and a 9?
A 1.
A 1, and that's going to be the only thing they have in common. All right, so for my second parentheses, a negative x divided by negative 1 makes that a positive x. And then your positive 9 divided by negative 1 makes that a negative 9. At this point, you see my parentheses are all matched up. Everybody has to have those parentheses match up, okay? Now let's see what y'all think about this. Now that I got this factored like this, what would I put into these two parentheses? What would I put in one of these and in the second? Y'all remember?
Will it be x squared minus 1 and 1, and then the other one x minus 9?
That's it. Perfect. Yeah, because see, since they both got an x minus 9 factor being multiplied, we take this x squared minus 1 and then the x minus 9. All right, now at this point, we don't have no parentheses, no exponents out here. So remember, I'm going to treat the exponents like a 1 for both of these factors, okay? All right, y'all, good job. So the last thing we got to do, remember, this is an x to the third. So that 3 tells us we got to get 3 zeros on this. So I'm going to take my first factor, x squared minus 1, set that equal to 0. And then my x minus 9, I'll set it equal to 0. So the first one, I'm going to, since it's got an x squared in a number, I'm going to add 1 and do my square roots to it. So you get an x squared equals a 1, and then you're going to square root both sides, which means this will be a plus or minus square root of 1. So y'all finally, I get x equals a plus or minus 1. So there's 2 of my zeros. The third one's sitting right here. On this one, I just got to add 9 to both sides. And I get my x equals 9 for my third zeros. So when I plug it in, I'll have a 1, negative 1, and 9. And all 3 zeros had a multiplicity of 1. Y'all, for number 4, everybody will have a multiplicity of 1 on that one, okay? All right, so we would plug that in, and I think that's how they wanted it, right? Just, yeah, we just got to list our zeros, and it don't even say what order. So we can do like a 1, comma, negative 1, comma, whoops. See, I would miss that because I got decimals there. So let me find a comma. There we go. And then negative 1, comma, and then I had a positive 9. And then I would come down here and say each one had a multiplicity of 1. All right, y'all, that's a trick on those. So I'm pretty sure 2 of y'all zeros are going to
I
be.
have a question.
I hear you.
Go back. Can you go back to your notes for question 4?
For the one I just did, yeah. Let me go back. Okay.
How does how do you go from like the x squared with the parentheses x minus 9, and then get x squared minus 1 out of that?
Okay, so what we're doing here, at this point, I had the x squared x minus 9 minus 1 times x minus 9. So the next step is to take the stuff on the outside, which is the x squared and the negative 1. So the stuff on the
Right.
outside here becomes one of your parentheses. And then the stuff in the parentheses, since it matches, it becomes your second parentheses. So you're sort of undoing the distributive property. Now, if you look at this right here, what I got right here, if you're going to FOIL this, you would do x squared times x minus 9, and then you would do the negative 1 times x, and then the negative 9. So you're just sort of going in reverse on that, okay? So the outside becomes one parentheses, and the stuff inside will always become your second one.
Okay, that makes sense. Thank you.
All right, y'all, let's see what this one says. All right, so let's think about this one, and I'll tell you what we're looking at on these. So if P of X equals X minus 2 squared times X plus 5 cubed, then they want to know, does this cross the X-axis at 2, 0, true or false? So y'all, I'm going to write this. P of X equals X minus 2 squared times X plus 5 cubed. Then they're saying we're going to cross at 2, 0. All right, so let's go and look at that one, and I'll show you what I'm looking at on this one. All right, so we had a thing that was talking about these degrees. My degree 2 here, and I got a degree 3 here. So we had some rules. If the degree was even, so if your degree is even, then it's going to be tangent at the x-axis. So it's not going to cross, it's just going to come down, touch it, and then turn back up. If the degree was odd, well, if it had an odd degree, then it crosses right over the x-axis. All right, y'all, so they want to know at this 2, 0. Well, you got to figure out which factor the 2, 0 came out of. Well, if I said x minus 2 equal to 0, that's the factor that would have gave me that 2. The other one, x plus 5, if you said it equal to 0, you would have got a negative 5. So since this is 2, 0, we're looking at this first factor that has an exponent of 2, which means your degree is even. But we said if the degree was even, it was going to be tangent at the x-axis and not cross. So this is definitely going to be false when we go look at it, okay? So even exponents are tangent, remember. Odd exponents are going to cross. So let's go find which one of these answers we need, because they got 4 answers, okay? So we said false, so it's either going to be A or D. So let's look at what it says. It says it's false because x minus 2 is a factor and the exponent 2 is even. Thus, it's tangent to the x-axis. That sounds like what I need, but I'll look at D too. So D down here says it's false because x minus 2 squared is a factor and the exponent 2 is odd. So right there's where that one's bad because it's calling the even exponent odd, okay? So make sure you get the one where it says the 2 is even on that one. All right, y'all, let's see what's next. Number 6 here. Okay, so let me show you real quick what I'm looking at on this one, and then we'll answer this. So we're looking at the maximum number of real zeros. We want the maximum x-intercepts. And then we want the maximum turning points. All right, well, the maximum number of real zeros is equal to the degree of that polynomial, which is the highest exponent. The maximum x-intercepts is equal to the degree of that polynomial, which is the highest exponents. These two are always going to be the same. Because remember, x-intercepts, the x value is the same as your zeros, okay? So these two got to be the same. Now, the maximum turning points is going to be the degree minus 1. So if you get a high exponent here, it's going to be the same here. And then you're going to subtract 1 to get the turning points, okay? And y'all, that's all I'm doing on that question. So let's go find my highest exponent. So what is our degree of this polynomial?
7.
All right, so I'm going to put a 7 there. And good job. That means we're going to put a 7 on that one. And then on the last answer, you're going to put 1 less, which is a 6. So y'all look at your polynomial, find out what that exponent is, and then the first two will equal that. The third one, you're going to subtract 1, okay? All right, y'all, the next two go back to the chart I had. The very first chart I showed y'all. So let me bring that up again real quick. Now look at this one. I'm looking at a 1/2 x squared. So we're looking at one with an even degree of 2, that's even, and a positive 1/2. And what I'm looking at is my chart here. So even degrees are in this column. If the lead coefficient's positive, you got that picture. If it was negative, you would have this picture. Well, mine was a 1/2 x squared, I think. So it was an even degree, positive lead coefficient. So both ends of my graph are going to go up. And that's all you got to do to that. Let's find one that has both ends going up. Well, A is going uphill left to right. B, both ends are going up. C is going downhill. And then D, both ends are going down. So y'all, the only one we can choose would be this B here. And I'll make it larger so that you can see both ends of that are going up, okay? Same thing on number 8 here. Number 8 is a negative x to the 5th. So let's go back to that chart. I got an odd degree with a -1 lead coefficient. So we're odd and negative. All right, so odd degrees over here. Positive lead coefficient is that picture. Negative lead coefficient would be this picture. So since mine was odd of a 5 and my lead coefficient was -1 in front of that x, mine needs to go downhill, left to right. So y'all, I would go back and pick which one went downhill. A, they're both going up. B, they're both going down.
D.
C, yeah, that's it, right? It's going uphill, left to right. And then D is sort of going downhill. So good job. Oh, I actually needed D, you said, I think.
Yeah, I thought D, but
Yeah, it's D. C would be if that was a positive 1 instead of a -1. So since ours was negative, it's going downhill. Good job. Oh, y'all, look at that. Now the fun begins. They want me to find the polynomial of degree 3 with the following zeros. So my zeros are going to be -2, 3, and -5. Now y'all notice that. They got everything in this except whatever's going in front of that x squared. So I know when I'm done, it better be an x cubed plus some number there for the x squared. And then we better get a -11x and a -30. So if we foil this right, we better get everything they got, and then we can figure out what that second number will be, okay? So we're going to go in and have fun foiling. So these ones, when they gave you zeros, you set up all your answers. So x will equal -2, x equals 3, and then x will equal a -5. And then I try to get zeros on the right side, so I'm going to add 2, subtract 3, and add 5. So add 2, subtract 3 from that one. And remember, I'm just trying to get zeros on the right side. And then here, since that's negative, we will add 5. All right, we had 3 equations equal to 0. So this is where I put everybody in parentheses and set this whole thing equal to 0. All right, so now I'm just going to start foiling. So what I'm going to do is bring down the x plus 2 here. And I'm going to start by foiling these two right here. So y'all always did those parts on the side. So let's do our x minus 3 times x plus 5. All right, y'all, so x times x gave me an x squared. X times 5 gave me a 5x. Then on the inside, negative 3 times x is a negative 3x. And then negative 3 times 5 was a negative 15. You're going to add the like terms and end up with an x squared. 5 minus 3 gave me 2x. And then minus 15. So I'm going to put that in my second parentheses. X squared plus 2x minus 15, all equal to 0. All right, so now we got to multiply all this stuff. So I'll do that on the side, I guess. And remember, all I'm looking for is what number is going to end up in front of that x squared term, okay? So my x plus 2 times my x squared plus 2x minus 15. So now these got to multiply by all 3 over here. So the x squared gave me an x cubed. The x times 2x is a 2x squared. And then the x times negative 15 was a negative 15x. Now multiply everybody by the 2. The 2 times x squared is a 2x squared. 2 times 2x is a 4x. And then 2 times negative 15 was a negative 30. All right, so now I'm just going to add my like terms. So I got my x cubed. Oh, let's see, what do we got? 2x squareds. There's 2x squareds, so those are like terms. So that's going to give me 4x squareds. So y'all, I'm thinking it's going to be a 4 we need to put in there. Let's finish it out though. Negative 15x and 4x is a negative 11x. And then at the end is our negative 30. So that's what I would put here, but all I was looking for was one number on this whole thing. What's in front of my x squared is the 4. And then y'all, everything else matched up what they had, okay? So we're just going to go back into that and put a 4 in. And y'all, there's my negative 11 like we had, negative 30. So we're going to put a 4 right there. All right, y'all, questions on these yet? So y'all good? All right, y'all, so let's do this on this one then. Same thing. Now they're giving me an A, B, C, D choice on this one, but I'm having zeros of a square root of 2, a negative square root of 2, and a 3. So remember, if you get radicals, they got to come in conjugate pairs. So if you get a positive radical, you automatically need that negative one, okay? All right, so let's go foil this stuff. So these, number 9 and 10, you're doing a little bit of foiling on these, okay? All right. I always put my number first. So I'm just going to put my x equals 3 first. And then my x equals a square root of 2. And then x equals a negative square root of 2. Subtract and add like we need to get them zeros. So I'm going to subtract 3. I'm going to subtract the square root of 2. And then here we're going to add the square root of 2. All right, same thing I did here. I'm going to put them all in parentheses. Now, me, myself, I'm a little picky on this one. I'm going to bring down that x minus 3. And I'm going to start by foiling this stuff right here on the side. X minus square root of 2 times x plus square root of 2. Since these are conjugate pairs, the radicals are going to disappear. So y'all, here's my question. Foil that and tell me what we're going to get out of that. And if y'all foil that right, you should not have any radicals left, okay?
Is it just going to be x squared?
Well, you're going to get an x squared for sure. But what's going to happen at that end of that? So, y'all, here's that x squared. You got the x squared. X times x was an x squared. Now, I'll foil it out all the way. If you do x times square root of 2, you get a square root of 2 times x. Here you get a negative square root of 2 times x. So those are going to cancel because one's positive and one's negative. But what are you going to get with that negative square root of 2 times a positive square root of 2? That gives you a negative square root of 4. So they canceled in the middle right here for sure. So bring down your x squared minus, well, what's the square root of 4?
2.
2. So remember, these ones you always ended up with the radical times the radical always gives you the number under that radical, okay? All right, so that's going to go there. So the last thing I got to do now is foil this stuff. And then I'll be able to pick A, B, C, or D.
Oh, you wrote x squared minus 4.
Oh, x squared minus 2. My bad. Whew, I'd have never got one of my answers, would I? So y'all make sure that is a 2 there. Okay, that looks more like 2. Okay, I know I was talking about that 4 and then I wrote that dang 4 down. Okay. All right, so whatever we get here, we want in here for sure, right? All right, y'all, there we go. X times x squared is an x cubed. X times negative 2 is a negative 2x. Then I would do negative 3 times x squared is a negative 3x squared. And then negative 3 times negative 2 is a positive 6. So the only thing you would do here was just rearrange the order so that you end up with an x cubed minus the 3x squared, then minus the 2x, and then plus your 6. And I think all math lab will do is put what, a f of x here. So we want one that matches that on that A, B, C, and D, okay? So let me see here. So I had an x cubed minus 3x squared minus 2x plus 6. So I would definitely go with B on that one, okay? Now I'll tell you this, since they gave you 3 zeros, a square root of 2, negative square root of 2, and a 3, it can only be one of these with an x cubed answer, okay? So it had to be ABC. It couldn't have been D because that's got an x4. And that means they had 4 zeros on that one. All right, y'all, let me see what's now this one we don't even have to workout on another page. They're
Yeah,
giving me a polynomial degree 4, and it has some of these zeros. It has a 0 of a negative I, and then it has a 0 of a 2 minus square root of 11. So here's the question. If that's a degree 4, you got 4 zeros altogether. They gave us 2 of them. What are my other 2 zeros?
I and then 2 plus the square root of 11.
Oh, look at you go. There we go. I, comma, 2 plus, and where's that square root down here? Square root of 11. Good job. So on number 11, you need 2 conjugates to the 2 that they're giving you, okay? So knowing that on number 12 here, they're saying, well, hey, I got a polynomial. I'm not going to tell you the degree, but it has some of these zeros. You have a 0 over negative 5i, and you have a 0 over 2. They want me to FOIL all this stuff and get them a polynomial. But what's missing?
Can you go back to the last one? I'm
Number
confused.
11.
Yes.
My notes are their notes.
Just I don't know. I'm confused. I got lost.
On this one?
Yes.
Okay, so here's the thing on this one. For number 11, they're going to give you 2 zeros. What you got to realize is that you see that negative I? I's always come in conjugate pairs. So if a negative I is a 0, then its conjugate pair is a positive I. Also has to be a 0. If y'all have a negative 2i, then you need a 2i for your answer, okay? On the radical one, they gave me 2 minus square root of 11. Well, the radicals always come in conjugate pairs also. So if you got 2 minus square root of 11, then you automatically will have a 2 plus square root of 11. Okay, so you're just going to change the signs on the I and on the radical part, okay? And then that's all they're doing on that one is just like this one. Look right here. I'm going to have to do some foiling here and come up with a polynomial. Now they're giving me some of the zeros it's saying. So what automatically has to be a 0 of this also?
Positive negative 5i.
A positive and a negative
5i.
5i. So since they gave me the negative 5i, we automatically know that 5i also has to be a 0. So this one you're going to FOIL though, but you had to know that for this one. So they gave me negative 5i and 2, so that meant 5i is also a 0 automatically. Okay, so you're going to have 3 zeros. Now I'm going to put my number first, my x equals 2, and then x equals negative 5i, and then x equals a positive 5i. So number 12 is going off of number 11 to make you realize that if I give you this, that's automatically a 0 too, okay? All right, add and subtract. So here I'll subtract 2. This one I'll add 5i. And then on the third one, I'll subtract 5i. All right, all 3 of these are set equal to 0. I'm going to put them in parentheses. Now, I'm going to bring down that x minus 2 because me personally, I'm going to start by, well, you got to FOIL these conjugate pairs first. So on the side, that's the first thing you need to FOIL. X plus 5i, x minus 5i. All right, let's see now. The i's will cancel on this one just like the radicals canceled on the last one. That's the property of conjugate pairs, okay? All right, y'all, here we go. X times x is x squared. X times negative 5i is a negative 5ix. 5i times x is a positive 5ix. And then y'all watch this. 5i times negative 5i is a negative 25i squared. So you see the i's in the middle cancel. A negative 5i and a positive 5i, they cancel. Hey, let me ask y'all this. Do y'all remember what I squared equals?
-1.
-1. So I'm replacing the I squared with a -1, okay? So that's going to give me an x squared. That negative 25 times that -1 will make that a positive 25. So the conjugate pairs of the imaginaries will always be plus the number, okay? All right, so we're going to put that here. And then finally, we're going to FOIL this and be done with this, okay? And now this one, I have to write the whole thing in, I think. So x times x squared is x cubed. X times 25 is 25x. -2 times x squared is a negative 2x squared. And then that -2 times 25 is a negative 50. Now, the only thing I would do to that is rearrange it and have an x cubed minus 2x squared plus 25x minus my 50. So that's what we're going to put into that box they got for us, okay? Because it should say the polynomial is, and let's see. Yeah, so see, they say the polynomial in expanded form is f of x equals x cubed, so x exponent 3, arrowed over. Okay, arrowed over. Minus 2x squared. And then plus 25x. And then minus R50. So you don't put the f of x or anything. They've already got that there for us, okay? So we're just actually putting in the polynomial only. All right, y'all, let's see what was that, 12? So we're on 13. All right, 13. They're going to give you a polynomial. So I got p of x equals x to the fourth plus 27x squared minus 324. So I'm finding all the zeros, and they're telling me 6i is a zero. So remember this. That's an x to the 4. So I need 4 zeros altogether. They're giving me 1. So I got to find the other 3 zeros and put into that box. So let's go work this one. Now, we'll say this. To work this one, I'm going to do synthetic division. I'm going to start with the 0 they're giving me, 6i. And then once I get me my remainder of 0, I got to get a 0 for the remainder since it is a 0, okay? So then I'll show you my next step. So synthetic division, you need to write out all the coefficients. Now, there's not an x cubed up here. So since there's not an x cubed, I'll put a 0 in place of it. And then it goes from x squared to the number. So since there's not an x term, I need to add a 0. So y'all are going to have the same setup as me. So bring down a 1 for the x4. 0x cubed. A 27 for the x squared. 0 x's. And then your constant term or your number is a negative 324. Y'all, on this problem, you're going to need 5 numbers starting. So that means y'all will be using 2 zeros just like me, okay? All righty. Synthetic division, bring the 1 down. 1 times 6i is 6i. 0 plus 6i is 6i. 6i times 6i is 36i squared. So that I squared is going to make that a negative 36. Now you can multiply I times i's on your calculator, okay? I'll show you this on your calculator here. There's an I right above this. You can't see mine, but there's a little blue I right here. So if I do 6 and then second dot, that brings up a 6i times 6, second decimal, and hit enter. There's that negative 36, okay? All right. 27 to negative 36 is a negative 9. Negative 9 times 6i is a negative 54i. 0 and negative 54i is a negative 54i. And y'all watch this. 6i times that negative 54i. Negative 54, second decimal, times 6i gives me a positive 324. Negative 324, I'm getting bad on my numbers. That's a positive 324 there. Negative 324, positive 324 gives me a remainder of 0. But you knew you'd get a 0 there because they gave you this one. So y'all, now we take these 4 numbers, 1, 6i, negative 9, and negative 54i, and we need to try another 0 over here. Because as long as you still got 4 numbers, we can't do the quadratic stuff. So what would y'all try as your next 0?
Negative 6i.
Negative 6i. Because these ones come in conjugate pairs. Perfect. All right, y'all, watch this. The 1 comes down. 1 times negative 6i is a negative 6i. Well, 6i and negative 6i give you 0. 0 times negative 6i is 0. Negative 9 plus 0 is negative 9. And y'all, negative 9 times negative 6i is a positive 54i. Add them and you get a 0 remainder. So our first of the 3 zeros is going to be negative 6i. Now to find the other 2, you're going to have 3 numbers here. That's your x squared term, your x, and your number. So what I basically got is an x squared minus 9. Since I don't have 0 x's in the middle, you're going to set that equal to 0 and solve it. So we got an x squared minus 9 equals 0. So that x squared is going to give me the last 2 zeros, okay? And y'all, what I would do to this, add 9.
What did you say the 1, 0, negative 9 equal? It's the x squared.
Say again?
So before you started doing the x squared minus 9, you said the 1, the 0, and the negative 9 equal x squared and what?
So this is your x squared term right here.
Right.
This 0 is your x term.
Uh-huh.
And then this negative 9 is your constant or your number term at the end.
Okay.
So, but since I had a 0 here, I didn't have to use it on here. Now, if you wanted to, you could take these 3 numbers. Y'all remember that in week 5 of your content folders, you had a quadratic formula website you can go to. So there's a little website we gave y'all in week 5, I think it was, and it was a quadratic formula calculator. If you go to that, you can punch in A is 1, B is 0, C is negative 9, it'll give you the two answers I'm about to give. But that quadratic formula, it was in your week 5 folder, okay? All right, y'all, to solve this, I'm going to add 9 and do my square roots. So I get x squared equals 9. I'm going to square root both sides. So since that's a number, I'm going to get a plus or minus square root of 9. So y'all square root of x squared gives me an x. And that's going to be what? A plus or minus square root of 9 is 3. So the other zeros are going to be the negative 6i, and then a 3 and a negative 3. We don't put in the 6i. That's the one they gave us. They only want 3 of them, not all 4 of them, okay? So you would come back here and see it says the remaining zeros. So negative 6i, comma, then what? 3, comma, negative 3. Okay, so on that one, you're just putting 3 of them in there and then hit next. Alrighty, so they want vertical asymptotes. They're giving us f of x equals x squared plus 5x minus 14 over x squared minus 2x minus 8. Now this one, I'm going to go to my page. To find vertical asymptotes, I'm going to take the bottom of this and set it equal to 0. Don't worry about the top, only the bottom. Because the vertical asymptotes occur where this is undefined. Now, I'm going to factor this to solve it. But y'all, you could use that quadratic formula calculator in week 5 and punch in a 1, negative 2, and negative 8. And it'll give you the two answers that I'm about to get eventually, okay? So for this one, I got an x squared is an x and an x. The last sign is negative, so you automatically got a plus and a negative here. Now, the larger factor will be negative like the middle. So I want factors of 8 that'll subtract and give me a 2. Well, 8 is going to be a 1 and an 8 or a 2 and a 4. The 2 that subtract to give me the 2 in the middle would be the 4 and the 2. So the larger number is going to be negative like the middle. So the 4 is negative and the 2 will be positive. All right, solve both of these now. Set each of these factors equal to 0. So the first one, I would subtract 2 and get x is a negative 2. The second one, I would add 4 and get x is a positive 4. So I'm going to go back to the test and I want x equals negative 2 and x equals 4. Okay? Now, you could factor the top and see if any of them canceled, but on this number 14, none of these are going to cancel on ours. So we'll just keep both of those, okay? All right, we had x. Now watch out, they put a y in here. We don't want y. We need the ones with the x's. And there was my, whoops, I had a 4 and a negative 2. I need b here, don't I? So they put the right answer on A, but they used the wrong variable. Ours is x's, okay? So x was negative 2 and x was 4. Alrighty, domain, and we want it in interval notation, so they're giving us f of x equals 1 over x squared plus 2x minus 35. All right, y'all, so the domain is the same as those vertical asymptotes. We're going to take the bottom of this, set it equal to 0. Now, you can get the two answers by factoring it like I'm about to, or you could use the quadratic formula calculator in week 5 and punch in a 1, 2, and negative 35. It'll give you the same answers that we're about to get factoring this. All right, x squared is an x and an x. This last number is negative. So remember, the last number is negative. That means one's positive, one's negative. Now, this time, a larger factor will be positive since the middle's positive. So y'all want factors of 35, that'll subtract and give me a 2. So for 35, that's either going to be 1 and 35, 5 and 7. The 2 I need are 5 and 7. The larger factor 7 will be positive like the middle, and then the 5 negative. All right, then you will set both of these equal to 0 and solve them. So y'all, the first one, you're going to subtract 7. The second one, you're going to add 5. So you have the two numbers you're going to exclude from the domain, which means our domain, in interval notation, we're going to start at negative infinity. We're going to cruise until we hit which number first? Looks like negative 7. You're going to union around negative 7 till you hit that 5. You're going to kick out that 5 by unioning around that 5. And then we're going to head towards positive infinity. So whatever numbers you get are the two numbers you're going to kick out, okay? So this right here is what MATLAB's going to want. So y'all, let me see how they got this. So we're going to come in here, parentheses, start at negative infinity. There's an infinity down here. And then comma, that's going to go to negative 7. Close parentheses.
So does the top number matter at all?
No. Only that bottom, okay? And it's all because you can't divide by 0. So the top can be a 0, but the bottom can't. All right, so negative 7 was the 5. I'm going to union around that 5. And then from 5, we said we're headed off towards a positive infinity. Okay? So yeah, for the asymptote, the vertical asymptote, and for this domain, you're only focusing on that bottom, okay? All right, so y'all, this was the horizontal asymptote. I gave y'all 3 cases for a horizontal asymptote. I said if the degree on top was bigger than the degree on bottom, there would be no horizontal asymptote. If the top degree was less than the degree of the bottom, then it would be y equals 0. If the top degree equaled the bottom degree, then we had to look at A over B, which were those lead coefficients. Well, y'all look here. We got a degree of 4 on top. We got a degree 4 on the bottom, because that's my biggest exponents. So they're equal. So since they're equal, I got to look at the lead coefficients of both of these. So this is going to be like the A over B pattern. So I'm going to have A equals, well, my lead coefficients are the 4/3. So that's going to be a 4 divided by 3. So pretty much everybody's number 16 will probably have the same degree here on top and bottom. So you're just going to be looking at those lead coefficients, okay? All righty, y'all. So that's it on that. So 17 wants the domain. They want me to get the x-intercept and the y-intercepts and then choose one of these 4 graphs. So y'all, all you got is an x on bottom of this. So y'all, that means since you got a single x on the bottom, What's the only number y'all got to kick out of your domain? What y'all think?
0?
0. Because you're going to set that x equal to 0. There's nothing else to do to it. So that means we're going to kick out a 0. And y'all, they got my 3 domains listed here. Negative infinity, infinity. Wrong. Here we go. Negative infinity to 0, union 0 to positive infinity. So since 0 is the only number you're kicking out, you would pick B. Now, what did they get on C? They got a 4. They probably played with that top somehow. All righty. So let me write this down and I'll show y'all how to get those x and y intercepts. So f of x equaled 4x plus 2 over x. So I'm going to show you how to get the x and y intercepts on this, and then we'll come back and put them in, okay? All right, so to get your x-intercept, you set the top of the fraction equal to 0. So that is a 4x plus 2. We set that equal to 0, solve it for the x, and then I'll put it as an ordered pair. So on this one, you're going to subtract 2. That's going to give me 4x equals that negative 2. I'm going to divide both sides by 4. So that cancels. I get my x equals. So that's going to be a negative. Y'all, what would y'all turn a 2 over 4 into?
1/2.
Negative 1/2. Good job. Now, to put this in the math lab, it's going to be a negative 1/2 for the x and a 0 for the y. So remember, the x-intercept has to have a 0 for the y. All right, they want me to find the y-intercept also. So to find the y-intercept, you find f of 0. That means you're going to put a 0 in for all the x's. So you got 4 times 0 plus 2 on top over 0 on the bottom. So can you even work this thing? I mean, you can do the top. 4 times 0 is 0. 0 plus 2 is 2. But that's going to give you 2 over 0. What's happening there?
Can't do that, right?
No, you can't do that because anything divided by 0 is undefined. So if you got a single x on the bottom, you're going to have a 0 on the bottom when you do f of 0. That's undefined. And anytime it's undefined, that means there's no y-intercept. But y'all, we can't have a y-intercept because we said if you put a 0 in for that, it made it undefined anyway. So there's no y-intercept. My x-intercept was negative 1/2 and 0. So let's put those on. So see, it'll say the x-intercept here. You have to put it in the parentheses. So parentheses, negative 1/2. And then arrow over, that'd be a comma 0. All right, then look here for the y-intercept, I would choose B that says there is no y-intercept. Now, let me go and graph this real quick. That way we can choose A, B, C, or D. Okay? So to graph that, I'm going to go to y equals. I'm going to make it look like a fraction, so I'm going to hit the green alpha button and the y equals and enter. On top, I had 4x plus 2. And then arrow down the bottom, I had an x. If you don't use fraction notation when you put this in, you need to put the 4x plus 2 in parentheses and then divide by the x. Okay? All right, so let's see what the graph is. So there's the x-intercept that's coming across the x-axis at that negative 1/2. And it's going down, and then the other side is, it's trying to approach 4, it looks like. Because if you look at the horizontal asymptote, since the x on top matches the x on bottom, it would be 4 over 1, which is 4. So we want the one that looks like this picture right there. So go back to our graph. So it was above. So y'all, looks like D to me. Let me make that a little bigger for you. See how it's coming down at that -1/2 on the x-axis? And looks like they're about at 4 on that one. So D is what I'm choosing, okay? Looks like C's on the wrong side. Same thing with A. It went up instead of down. So yeah. All right, now the last three are just solving inequalities. So 18 has x minus 4 times x plus 3 is less than 0. Now they want me to write these in interval notation, okay? So for 18 here, it's already factored. So we're just going to take both factors, set them equal to 0. All right, so here you're going to add 4 and get x equals 4. This one you're going to subtract 3 and get x equals -3. But y'all remember on these, I made number line. And let's see, -3 is on the left side and a +4 is on the right side. I use my solutions to set up my number line. I'm going to test 0, and 0 is going to be in between that -3 and 4. So 0 is in here somewhere. If it's true, I'm going to shade that. If it's false, I'm going to shade the outside edges. So let's put a 0 in for these x's and see if this is true or false. 0 minus 4 times 0 plus 3 has to be less than 0. So y'all, this is going to give me a -4 times +3 has to be less than 0. All right, so that's going to give us what, a -12 less than 0. So y'all, is that true or false?
Yeah, that's true.
That's true. So what that means is we would come back here and shade that middle section since it was true for 0. Now let's write this answer in interval notation. So my question is, when I do interval notation, am I going to use parentheses or would I use brackets?
Parentheses. It's not
Parentheses.
equal to.
Exactly, because you don't have an equal sign under that, remember. You only use brackets if it's equal under that. So since it's just a less than, we're going to use parentheses. We're going to start at -3 and go to 4 and close parentheses. So your interval has to match your number line there, okay? And since it's only true between -3 and 4, that's only two numbers you got in your answer, okay? So we're going to go put in a -3 and 4 for that one. And y'all, you got to put A and then put them in parentheses from -3, comma, 4, and then close parentheses. Now, 19 will be the same thing. The difference on 19 is we got to factor it, okay? So let's see what we get on this 19. So 19, we got to factor x squared minus 9x plus 14 greater than 0. All righty, y'all. So let's go play with that one. All right, let me move that back up. So this one I got to factor. And then when I factor it, I'm going to set it equal to 0, okay? So you got an x squared is an x and an x. Now, you could put in a 1, -9, and a 14 on that quadratic formula calculator website we give you, and it'll give you your two answers, okay? But y'all watch this. The last one's positive. Anytime the last number's positive, both of these factors will be the same sign as the middle. So that means both of these are going to be negative. And then I'm going to find factors of 14 that add to get a 9. That's going to be a 7 and a 2. All right, so it's factored. I can set both of them equal to 0 now. And solve this one by adding 7 So I get x equals a positive 7. This one I'm going to add 2 to both sides and get x is a positive 2. So for this number line, let's see who's first. 2 is here and 7 is here. So notice this time my 0 is going to be before the 2. 0 is going to be on the first section. So if it's true for this section, I automatically shade the last section. If it's false for this section, then I'm only going to shade the middle, okay? So I'm going to take the top equation, put zeros in. So 0 squared minus 9 times 0 plus 14 has to be greater than 0. Well, that's a 0. That's a 0, so they're gone. So 14 greater than 0, true or false?
True.
That is definitely true, y'all. So since it's true for this section, I'm going to shade it. And if you shade the first section, you automatically got to shade the last section. All right, y'all. So interval notation based off of this one, when you shade the first section, that means you're going to start at negative infinity until you hit that 2. Parentheses or brackets?
Parentheses.
Parentheses, because it's still no equals under that. Now, here's where I get people. You're going to union this, but you're not going to union it from the 2 to the 7, because that's not true. You're going to start at this 7 over here. And from 7, you're going to positive infinity. So see, in between 2 and 7, you can't have that in your answer, okay? All right, y'all. So you would put that into that thing. You would come back. You do parentheses, negative infinity, comma 2, close parentheses, and then union parentheses from 7 to positive infinity. And then close your parentheses. Okay? All right, let's see what we got at number 20. So the same thing, but now we got to do a little more work. You got an x squared plus 19 less than 8x. So y'all, let's work this one and see what we get. All right, so the first thing I need to get a 0 over here. So we're going to subtract 8x from both sides. So I get my 8x squared minus my 8x plus my 19 less than 0. Now I'm going to factor that. So x squared is an x and an x. This last sign is positive again. So that means both of these will be negative like the middle. And y'all, let's see. I need factors of 19 that'll add to get an 8. But y'all think the only way to get a 19 is 1 times 19. So that's not going to add and get me a 8. So this one does not factor. I don't think anybody's number 18, I don't think none of y'all's number 20 is going to be able to factor. But since it does not factor, what was my solution? Do y'all remember that?
No.
Okay, so when it does not factor, it was what we called a no solution. And the no solution in MATLAB, you have to choose that 0 with the line through it. So y'all, let's go choose that and see what we got. Now it shows up when you click the answer blank down here. The one over here by more, you see that 0 with the line through it? You're going to click that and it's going to put it in the blanks for us. So everybody, here's a bonus for you. Everybody's number 20 will be that answer right there. And you know, at this point, I guess you would hit submit, right? That's all there is to it. And then, yeah, we want to confirm it and submit it. All right, y'all. So that is your Module 3 test.
I have a question.
I hear you.
So for the scratch work, one of the questions we have to do scratch work on is 20. How do you want us to do that? The same way we just did it?
Oh, so if 21, all you got to do is just put it does not factor, and that's it.
Okay.
I'll
I
be
didn't know
cool.
how to show work on that, so
Yeah,
that makes
because since it didn't factor, just put it does not factor, and that's all you got to give me, okay? All right, also, it's not that bad. You got them 20 questions. I'm going to quit recording so I can send this out to y'all later.